I was looking for how I can reduce development time, especially the part I don't like, that is unit testing. I found this library Pynguin, which generates unit tests automatically from given Python code. I will check out this framework and give my thoughts on it. So let's start. I'm installing it in a Python virtual environment. Pynguin wants us to set Pynguin danger aware environment variable. It is an acknowledgement that you are aware of the possible dangers of executing your code. That is, if your code deletes some data, then it might get deleted while generation of unit test, because Pynguin execute the code with different random inputs. Let's try the first example. We have a function that returns the type of the triangle given the length of its three sides. If all the sides are equal, it is an equilateral triangle. If any two sides are equal, it is an isosceles triangle. Otherwise, it is an scalene triangle. That is, all sides are unequal. I will copy and paste it in a file named example.py. To generate unit test, we use Pynguin command. We specify the project path, that is where our example file is. Since it is in the current working directory, we can just type dot. We will now specify the module of which we want to generate the unit test. Finally, we will specify the output path, that is where we want to store our generated unit test file. Since I want it in the current working directory, I type just a dot. Okay, let's run it. Our unit test files are generated. Let's check them out. It generated around 35 lines of unit test. In the first unit test, it passes bool false and asserts whether it is an equilateral triangle. One thing I notice here that even though the original functions types are specified clearly as integers, Pynguin doesn't take it into consideration and pass in bool as input. In the second test, it passed two sides as equal, asserted that it returns isosceles triangle. In the third test, in some lines it passed three different values and asserted that it is a scalene triangle. Overall, the generated tests have covered all the input scenarios. By the way, the algorithm behind the Pynguin unit test generation is designed to maximize the code coverage. So initially it generates many tests and a lot of them are redundant and keep only enough unit tests which maximizes the code coverage, discarding the other redundant tests. If you try yourself, you might not get the same test I have, but there are ways to get deterministic test. Anyway, this was a simple example. Let's try another one, which is a queue class. I copy the queue code and paste it in file example2.py. This has enqueue method to add item in the queue, a dequeue method to pop the first element, two other methods, full and empty, to check whether the queue is full or empty. Let's generate the unit test. The command will be the same as the previous one with just one change. Module name this time is example2 instead of example1. The tests are generated. Let's check out the file. It's generated 285 lines of test. Now that's impressive. It has generated unit tests covering all the lines of the code. I can see all the methods of class being called. Of course, it has a lot of redundant code which can be reduced, but anyway, it is still better than no test. I think this tool can be used to generate tests, but just skim through them once before accepting them. This approach might not be very useful if you do test-driven development, because you have to write your test before you write the code. But it will be useful when you write test afterwards, or you are given a testless codebase. It can also be useful when you are going to refactor your initial code. Suppose you have a piece of code that you have tested manually during development and now you think you can refactor it. In such cases, you can auto-generate the unit test and then refactor it. After refactoring, you can run all your tests to verify everything is intact. I think that's it for this video. I have provided the link in the description. You can check it out yourself. Thank you for watching.